So here's a lab demo for lab 6. Here are the two Cantbus chips here and the two Cantbus nodes. And then we've connected it to the DE1 here. And then here's a EEPROM chip from lab 5. And we have the ADC DAC chip here. And it's connected to the DE1 here. So for the demo, I'm going to share my screen. So first I'm going to load the SOF. And then once that's loaded, I'm going to press reset. And now we have to load the MIF file. So I'm going to go here, Tools, and System Memory Content Editor. And just for the part A of the lab. So import data from file. And then in my computer, C. And then programs, KP monitor code. And it's the MIF file, lab6.mif, open. And I'm going to write the data to system content memory. So in the video, you see that the hexes are like changing values. They're incrementing up, and the LEDs are also incrementing up. And then if you see the teraterm output, you see that the tasks are changing. I'll put my phone here, and then you see that like if I press reset, you see that task 1 is repeating every like after every 10 times the task 2 runs. So task 2 is incrementing faster. So task 1 is running basically in the code. It's running for every 1 second. So if I open the code, this example, so task 2 is running for every 100 milliseconds, and then task 1 is running every 1 second. So that's for part 1 of the lab. So I close this and I open this. So now I'm going to load the lab 6, the 6B part A. So I'm going to switch off the T1 and I'm going to restart it. And then for this part, I'm going to load the SOF again. So programmer, start. And then once the SOF is loaded, this part uses a hex file. So I'm going to load the hex file. And then file, send file. The hex file from part A. Open that. And then I'm going to run the G command. So you see these are the switch status, potentiometer, photoresistor, and the thermistor. So switch status, I'm just going to change my switches here. So let's say I change switch 2 to 1 position. You see that it's going to be 0, 1, 0, the last 3 bits. Now if I close switch 0, you see 0, 0, 0. Now I turn on 2 switches at a time. So the third bit, the second switch and the first switch, and you see 1, 1, 0 on the output. And I close both of them, or like I close the first one off. So it's 1, 0, 0. Now I close this one off, all zeros. And if I turn on switch 6 on, so it's switch 6 and switch 5 on, it's 0, 1, 1, 0. Now I turn off one of them, switch 5, and it's 0, 1, 0, 0. So I'm going to turn this one off as well. So for the potentiometer, I'm just going to change the knob here. You see the value changes to, it's like hard to notice, but it changes to 0. But then if I change it back, it changes to a negative something. It changes value. So now the photoresistor, I hover over it, I remove my arm. So the photoresistor is negative 16 there. So now I put my arm. Oh, I reset the thing, but then G. The photoresistor changes from negative 9 to negative 1 if I do that. And then the thermistor, I just place my hand there. And then you see, it's like hard to notice, but the thermistor values are changing. So the lab also asks us to remove the Cantbus node. So I'm going to remove one of them and 2 of them. And you see that the data transmission just stopped. And then I'm going to add the both of them back. And then yeah. So now you see the data transmission resumed, and I'm going to try the switches again. 1 0. And I'm going to turn all the switches on. And the last one on. So it's 1 1 1 1 1. So that's for part A. And for part B, I'm going to again close the switch off the device, turn it back on, start programming the SOF again. And now for this one, I'm going to open the IDE and then I'm going to edit the project because I have the part A's file here compiled. I'm going to delete it, insert, the program lab6, and I call this file, I call the part 6b, part B file Cantbus OS. So I'm going to open that, click OK, compile it, and you see no errors. And then I'm going to generate a MIF. So once the MIF is generated, I'm going to go to the in-system memory content editor. Import data from file. Load this MIF. And then write data to in-system memory. And you see this from the OS side of things. So if I reset, or like if I press reset, you see that so this is being called more often because it's every 100 milliseconds. And then the potentiometer is every 200 seconds. So it's 200 milliseconds. So after 2 switcher calls, you see the potentiometer here. So we know that it's happening every 200 milliseconds. Then after 5 switches calls, which is 500 milliseconds, then we see a photoresistor, which is supposed to repeat every 500 milliseconds. And then the thermistor is every 2 seconds. So it might appear a bit bottom. So then for this, I'm going to change the switches. And you see the screen changing like according to the switches. And I turn this one on. And you see the switch status for that changed. Turn this one off, turn both of them off. I'm going to try the potentiometer. And you see the potentiometer value also changes. For the photoresistor, I'm just going to put it here. Take over my arm. You see the difference? There's a difference from -16 to -2. So that's good. And the thermistor as well. Place my arm here. And then remove my arm. You see it changes a bit. And then I'll also again try removing the nodes here, both the Cantbus nodes. And you see the transmission stopped. So I'm going to put them back again. You see the transmission started working again. And yeah, that's it for the OS part as well. And I'm going to show you the code as well for that. So it's the Cantbus OS code. So it's the display. Display has a delay of 1 millisecond, so it keeps on displaying. And here's the mutex. We're protecting the transmit data and the ADC. And this similarly for all other functions. And there's the switches, and we're again protecting using mutex. And also the same here. So this 20 is 20 times 10, which is 200 milliseconds for the potentiometer. 10 times 10, which is 100 milliseconds for the switches. 50 times 10, which is 500 milliseconds for the photoresistor. And then 200 times 10, which is 2 seconds for the thermistor. And this is the display, and the display is least priority, and the first priority is obviously switches because that's the one that needs to be faster. And then followed by potentiometer, photoresistor, and thermistor. And there's some mutex here. And there's the initialization functions, and all the code for the functions are at the top here for the CAN controller and the I2C. So yeah, that's it for the lab demo. Thank you for watching.